Welcome to P. Clark Calc, Practical Calculus for the Busy Math Student. In this video we're going to take a look at one type of U-sub, call it the general log rule for integration. We're not integrating logs here, so what's going on? Let's take a look at it now. Here we're working on an integral that's going to require the general version of the log integration rule. And when we're doing log integrals, we're not actually integrating logs here. We're producing antiderivatives that are natural logs. And so from the general form of the simple rule, which we proved by antiderivative, we find that the integral of 1 over u du, if we can make that u substitution, is equal to the natural log of the absolute value of u plus c. Typically, when we're working with these in practice, we're looking for this. We're looking for integrals that in the form of du over u, or it's the differential of the denominator in the numerator. So basically, when we take a look at a rational function and we see, okay, I have a degree 3 in the denominator and there's degree 2 in the numerator, then that's telling us this has a good chance of working, and we would go ahead then and start writing up our u sub. Now in the case of if we're using log rule, u is the denominator, so we state that u here is 3x to the third plus 5. And then as always, we calculate our du. We're feeling confident it's going to work because of the 1 degree drop, but the differential du is 9x squared dx. So this is almost du. We see here that we're off by a factor of 9, and as long as we're off by a constant multiple factor, we can fix that. So in our integral, we're going to multiply the numerator by 9, and then we balance that by multiplying by 1/9 on the outside. And we see here kind of the classic case of the log integral. We see the derivative of the denominator in the numerator. Ultimately, when we say du, this dx factor is being thought of as being in the numerator, but ultimately it's usually not written that way. So we're looking for the derivative of the denominator in the numerator, and then we roll the dx factor into that to obtain our form in the u variable, which would be 1/9 times the integral of du over u. So that's most of the work. Once you get there, then the antiderivative is always the same. It's the natural log of the absolute value of u. We have our constant multiple of 1/9 here. And then we would go ahead and back substitute to get our antiderivative in x. And that gives us 1/9 times the natural log of the absolute value, 3x to the third plus 5, plus c. Now when we see the absolute value around the logorand in this antiderivative, that's a domain issue because you can only take the log of a positive value. So here, since 3x cubed plus 5 could be negative, we definitely need the absolute value symbols there. If you ever see them omitted, what it probably means is that the logorand can't be negative. That's going to be our antiderivative solution. One thing about log rule antiderivatives that sometimes drive people crazy, you have to remember your log properties here. The power rule for log says I could take that 1/9 and express that as an exponent of the logorand. So an equivalent form would be natural log of 3x cubed plus 5 to the 1/9 inside our absolute value. Or you could even see it expressed as a radical if for some reason you wanted to do that. That would be a 9th root. These are all equivalent forms of the same antiderivative. So it would depend what you'd want to use it for, but in most cases we leave it in the indicated form here in the box. And what you're looking for in order to do this type of integral is this fraction, this rational function, where the numerator appears to be something very close to the derivative of the denominator. If that's the case, go ahead and write up your u sub and see if it works by the log rule. If you want to learn more about u substitution integrals, you can find those on my textbooks available on Amazon. You can subscribe if you like the page here. And until next time, I see you. I'm P. Clark.